This is EU Geology Earth News. Today we're going to talk about the Majestic Catalinas just northeast of Tucson, Arizona. This area right here is part of the Catalinas. You're going to be seeing photographs to start with the camera being right about here, looking southeast at this ridge line. The top of the ridge is composed of granite, which trends to the southeast. Below the granite is metamorphic gneiss, which can be sedimentary or igneous. It can go either way, but then it's metamorphosed, either through different processes, but it's heat and pressure which does the metamorphosing, creating this gneiss. You can see there's layers to it. All the layers of the gneiss, and there's actually layers in the granite, seem to trend to the southeast. Geologists, I believe, would tell you that the southeast side, what I think is windward, used to be flat. And then the ridge was pulled up, exposing what had been underground on the northwest. So you get folding. So this folded, that folded, all of these folded, pulling up the northwest side, taking the flat surface that had been there and pulling it up in the air. This would be the northwest side. This would be the granite up here. This would be the gneiss down here. You can see the layers, and they all trend to the southeast, as this seems to also trend to the southeast, which doesn't make a lot of sense to me, but we'll look at a wider shot now. So this shows you the extent of the cliffs that run all along this ridge. It's Oro Valley down here. It's really nice. I recommend it. Now, instead of looking from here to the southeast, we're going to start looking from over here to the northeast. It'll be a completely different perspective. So here you see the granite, and down here the gneiss, and this all seems to be trending to the southeast, with I see leeward on this side making cliffs, just like the welded tuff formations have this same shape, where you have airborne dust that's very hot coming from a alleged volcano, producing these same patterns of a windward and leeward side. We'll keep going now towards the southeast and looking at the different angles. So now I'm continuing towards the southeast. Here's another look. This is the granite up here. It's trending to the southeast. We're going to look at this area in the next image. Here's the top layer, the granite. I see layers all trending back to the southeast, and granite coming from below. Doesn't seem like it should do this. This looks like it's an airborne deposit. That's what's been hanging me up for the last 6.5 years, as I've been seeing these airborne formations. In the beginning, not really understanding it, having a rather twisted view, thinking it was dunes instead of this welded tough process. But I think this shows it fairly nicely. We can zoom in a little bit, bring it down to the middle, zoom in. It looks like there's layers going to the right, which is to the southeast. In these next shots, I'm going to be down here somewhere. There's a trailhead that takes you up into these mountains. There's a parking lot for the trailhead. That's where I am. I'm going to be looking this way at this, what I see as the windward side of this ridge, with this as part of it, but you'll see the layering and how the directionality works. This shows windward. The wind was coming this way to the left. It creates this on windward and a cliff on leeward, and here's the canyon where that little stream runs down. So this stream would have been running very rapidly. It'd be hurricane conditions, filling it with water. Any dust that fell into this would be washed away. While this grew, the dust would fly past the ridge over to the other side, continuing the process. Here's another one that's quite clear. We'll look at close-ups of this in a moment. But this entire southeast side of the Catalinas seems to be airborne granite, which is insane. Actually, this one's a little out of order, but it shows things so nicely I wanted to go back to it. Here's windward over here. The cliff is on the other side. Here's the cliff with windward to the right. But this shows the edge of this granitic and gneiss formation. It seems like the wind was coming from the right. Now back to that last shot I skipped over. So here's a close-up of the canyon with windward, leeward. This territory, by the way, is some of the most beautiful country I've ever seen. I've been coming here since '72, and it's always taken my breath away. The high desert, the saguaro, the cholla, the different types of cactus are really something to see. And then here is the ridge that's to the right of the wide shot. This is the same thing as the ridges that we started with. These granite ridges where leeward seems to be to the northwest, which is to our left here. So, this mountain, I don't think bubbled up from below and eroded away slowly with gneiss underneath, which doesn't really seem to add up. How would the granite get through the gneiss? The gneiss would come up afterwards? I'd have to have somebody explain that to me, really. It's over my head. But this is another way of looking at the formation of mountains where you have access to molten dust from above. This is on the southern side of the main vortex that we've been looking at over this series, that yellow map of sediments. This is the southwest side. So here we are down here in southern Arizona, which is the southern part of this vortex, in my humble opinion. So I believe material was being pulled in from the southeast to the northwest here. Other places it's different. Over here it might be trending in the opposite direction. It might trend to the west, which leads me to believe these are vortices, not straight line winds. Tornadoes within hurricanes would be a decent analogy, I believe. Anyway, thank you very much.